All right, so today we're going to be diving deep into the atomists.
Okay.
And for this deep dive, we've got episode 9, The Atomists, from a podcast series.
All right.
And also Bertrand Russell's History of Western Philosophy.
Yeah, a great pairing.
Yeah, we're going to try to,
This is going to be good.
we're going to see what we can pull out of those and learn some cool stuff about the atomists.
I'm excited.
Yeah, me too. And,
Big topic.
it is a big topic. And, it's funny because this is just one episode
Right.
in a 61-part series
yeah.
on Western philosophy.
Yeah.
So we're going from the pre-Socratics
Yeah.
all the way up to modern times.
That's ambitious.
Yeah, it's pretty ambitious.
Yeah.
But we're going to try to make it as fun and as engaging as possible.
Sounds great.
So without further ado, let's jump right in. So the atomists, these guys were like the rock stars of ancient Greek philosophy.
Yeah.
They came up with this idea about the universe that was so ahead of its time, it's mind-blowing.
Yeah, and what's really remarkable is that they figured this stuff out without any of the fancy scientific tools we have today.
Right.
It was all just pure thought and observation, which is pretty incredible when you think about it.
Yeah, no microscopes, no particle accelerators, just their brains and the world around them.
Exactly. And yet they were able to come up with this idea that everything is made up of these tiny, indivisible particles called atoms.
It's almost like they had some kind of ancient Greek crystal ball or something,
Maybe. But seriously, it's a testament to the power of human reason and observation.
Absolutely. So let's set the stage here. We're talking ancient Greece, 5th century BC. What was going on in the world back then?
Well, it was a pretty tumultuous time, actually. You had the Peloponnesian War raging between Athens and Sparta.
Right.
A lot of political upheaval, and traditional beliefs and values were being questioned.
So kind of a time of crisis and change, like a societal shakeup.
Exactly. It was like the old ways of thinking were breaking down and new ideas were emerging.
And it's in this context that we get the atomists.
Right. Democritus and Leucippus.
These guys who dared to challenge the status quo and came up with this radical new way of looking at the universe.
Precisely. Instead of seeing the world as composed of the 4 elements, earth, air, fire, and water.
Which was the prevailing view back then, right?
Exactly, or as some kind of single, unchanging entity, they propose that everything is made up of these tiny, indivisible particles called atoms.
Okay, so this was a major break from the traditional way of thinking.
Absolutely. It was a complete paradigm shift.
So instead of a universe made up of these basic elements, it was all atoms, all the way down.
That's right. Atoms and the void, the empty space in which these atoms moved and interacted.
Wow, that's pretty radical.
It was. And they didn't stop there. They also proposed that these atoms were constantly in motion, colliding and combining in this infinite void.
So it wasn't just a static universe of tiny particles. It was a dynamic, ever-changing system.
Exactly. It was a universe driven by the movement and interaction of these fundamental building blocks. And this idea that everything is made up of atoms in constant motion is remarkably similar to our modern understanding of matter.
That's amazing. It's like they were peering through the centuries and catching a glimpse of modern physics.
Yeah.
But how did they explain the motion of these atoms? Did they believe in some kind of prime mover or a divine force that set everything in motion?
Actually, no. That's one of the things that makes the atomists so interesting. They rejected the need to explain the original cause of motion.
So they just accepted that motion is a fundamental property of the universe.
Precisely. They saw motion as inherent to the nature of atoms themselves.
And that's actually pretty consistent with modern physics, right? I mean, we don't really have a definitive answer for what caused the Big Bang.
That's right. We can trace the chain of causality back to a certain point, but ultimately we have to accept that motion simply is. And the atomists, remarkably, arrived at a similar conclusion over 2,000 years ago.
That's mind-blowing. It's like they were tapping into some deep truth about the universe that we're only now beginning to fully grasp.
It is remarkable, isn't it? And it highlights how even ancient philosophy can offer insights that are relevant to our understanding of the world today.
Absolutely. So we've got atoms swirling around in the void, colliding and combining to create the world we see around us. But how did this idea of atoms square with the other philosophical ideas floating around in ancient Greece? Like, what about Plato and his theory of forms? Were those two ideas compatible, or were they like oil and water?
That's a great question, and one that we'll definitely delve into as we continue our exploration of ancient Greek philosophy. But before we get there, let's take a closer look at the atomists' view of causality, because their idea that everything happens according to natural laws has had a profound impact on the development of Western thought.
Okay, so let's unpack that. How did the atomists explain why things happen the way they do? Did they believe in fate or chance or something else entirely?
Well, they definitely didn't believe in the gods controlling everything. They were firmly in the camp of natural explanations. They believed that everything happens according to natural laws.
Natural laws. So no Zeus throwing lightning bolts or Poseidon stirring up storms.
Nope, it was all about cause and effect, even if they didn't have the fancy equations to prove it.
So it was like a giant cosmic machine, everything running according to set rules.
Exactly. And this idea that everything happens according to natural laws is a cornerstone of modern science.
That's pretty amazing when you think about it. These guys, without any of the tools or technology we have today, came up with an idea that's still central to how we understand the universe.
It really is remarkable. In fact, Leucippus, one of the founders of atomism, famously said, "Naught happens for nothing, but everything from a ground and of necessity."
So basically everything has a cause, nothing happens randomly.
Precisely. And that idea that everything happens for a reason, that there's a cause and effect relationship behind everything we see, it's a fundamental principle in science.
I can see how that idea would be really revolutionary back then, especially in a world where people believed in gods and fate and all sorts of supernatural explanations for things.
It was a radical departure from the traditional ways of thinking. And even today, the idea that everything happens for a reason, it can be comforting, but it can also raise some tough questions, like if everything is predetermined, what about free will? Do we really have any control over our own destinies?
Those are big questions for sure, and
Yeah.
ones that philosophers have been grappling with for centuries.
Exactly. But for now, let's focus on the atomists and their amazing insights. Because even though their ideas were developed over 2,000 years ago, they're still relevant to our understanding of the universe today. And I think that's pretty incredible.
It is incredible. It's like these ancient Greek thinkers were throwing pebbles into a pond, and the ripples are still spreading outwards, even today.
We like that analogy. And those ripples have reached far and wide, influencing not just science, but also philosophy, art, and culture.
It's a reminder that ideas have power, and that even ideas that are thousands of years old can still shape the way we see the world.
Absolutely. And as we continue our journey through the history of Western philosophy, we'll see how these ideas from ancient Greece have evolved and transformed over time. But for now, let's take a break and savor the brilliance of the atomist, because their insights into the nature of matter and causality were truly groundbreaking, and they continue to inspire us today.
So we've got these tiny atoms swirling around, creating everything we see and experience.
And it's all happening according to natural laws, a cosmic dance of cause and effect.
It's a mind-blowing concept, and one that has shaped our understanding of the universe for centuries.
And as we'll see, it's just the beginning of our journey through the fascinating world of Western philosophy.
So stay tuned, because we've got a lot more ground to cover and a lot more amazing ideas to explore.
I can't wait. All right, so we were just talking about atoms in the void.
Right, the atomist's big idea.
Yeah, and how radical that was for their time.
Totally. It's still pretty mind-blowing even today when you think about it.
Yeah, and it's interesting because while the atomists were focused on this, kind of material explanation of the universe.
Right, like the nuts and bolts of reality.
Exactly. There were other thinkers in ancient Greece who were exploring different ways of understanding the world.
Okay, so different perspectives on the big questions.
Exactly. And one of those thinkers who had a really profound impact on Western thought was Pythagoras.
Oh yeah, Pythagoras, the triangle guy.
That's the one. The Pythagorean theorem, a squared plus b squared equals c squared.
Yeah, that brings back some memories from high school math.
I bet. But Pythagoras was much more than just a mathematician. He was a philosopher, a mystic, and a spiritual leader.
Okay, so more than just triangles then.
Much more. He and his followers believed that numbers were the key to understanding the universe.
Numbers, like 1, 2, 3. How can numbers explain everything?
Well, they believed that everything in the universe could be expressed through mathematical ratios and harmonies.
So it's like they saw the universe as one giant math equation.
In a way, yes. They believed that music, astronomy, and even morality could be understood through the lens of numbers.
Wow, that's pretty wild. So it's like they thought the universe was singing a mathematical tune.
Exactly. They believed there was a deep harmony and order to the universe that could be revealed through numbers.
Okay, I'm starting to see why Pythagoras has been so influential. But didn't this obsession with numbers get them into trouble at some point?
It did. Remember we were talking about incommensurables earlier?
Vaguely. Remind me what those are again.
Incommensurables are what we now call irrational numbers.
Irrational, like they didn't make sense.
Well, they didn't fit into the Pythagoreans' neat and tidy world of whole numbers and perfect ratios. You see, the Pythagoreans believed that all numbers could be expressed as a ratio of two whole numbers.
Okay, like fractions.
Exactly. But then they discovered numbers that couldn't be expressed that way, like the square root of 2.
The square root of 2, why is that one special?
Well, imagine you have a square with sides of length 1. According to the Pythagorean theorem, the diagonal of that square would be the square root of 2. But here's the thing. You can't find any two whole numbers that, when you divide them, give you the square root of 2.
So it's like a number that breaks the rules.
Exactly. And this discovery of incommensurables, it really threw a wrench into their whole system of belief. It showed that the world of mathematics was more complex and stranger than they had imagined.
That must have been a real shock to them. Did they try to ignore it?
They couldn't ignore it. It challenged the very foundation of their worldview.
So what did they do?
Well, ultimately, this discovery led to a deeper understanding of numbers. It forced mathematicians to expand their horizons and develop new concepts to deal with these irrational numbers.
So even though it was a challenge, it actually pushed mathematics forward.
Exactly. It was a crucial step in the development of mathematics as we know it today.
That's pretty amazing. It's like the stumbling block that turns into a stepping stone.
I like that. And it's a good reminder that even when our ideas are challenged, even when we encounter something that doesn't fit into our neat and tidy worldview, it can be an opportunity for growth and discovery.
Absolutely. So we've got the atomists with their atoms and the void, and we've got Pythagoras with his fascination with numbers. And now I'm wondering, how do these two different perspectives on reality fit together? Were they in dialogue with each other at all?
Well, it's hard to say for sure, as there's not a lot of direct evidence of interactions between the atomists and the Pythagoreans.
Right. It was a long time ago.
Exactly. But we can see how their ideas might have influenced each other. For example, the atomists' idea that atoms move and interact in the void
Right.
could have been influenced by the Pythagorean concept of harmony and proportion.
Okay, so maybe they weren't completely isolated from each other.
Right. And it's likely that there was some cross-pollination of ideas happening in ancient Greece.
Like a philosophical melting pot.
Exactly. And out of this melting pot emerged some of the most influential ideas in Western history.
Ideas that are still shaping how we think about the world today.
Absolutely. And as we continue our deep dive, we'll explore even more of these fascinating ideas and see how they've shaped the course of Western thought. So we've been talking about all these different ideas floating around ancient Greece.
Yeah, it's like a whirlwind of philosophical thought.
Exactly. And it's amazing how out of all this intellectual ferment, some ideas emerged that were way ahead of their time.
Like the atomists' theory of atoms. It's mind-blowing how close they came to our modern understanding of matter.
It really is. And, it wasn't just their idea of atoms, but also their view of causality.
Right, their belief that everything happens according to natural laws.
Exactly. And that idea has had a profound impact on the development of Western thought.
So no more Zeus throwing lightning bolts or Poseidon stirring up the seas.
Nope. It was all about cause and effect, a universe governed by natural laws.
And that's a cornerstone of modern science, right? The idea that the universe operates according to predictable patterns and principles.
Precisely. And it's remarkable how the atomists, without any of the scientific tools we have today, arrived at that conclusion.
It's like they were tapping into some fundamental truth about the universe.
It is. And another thing that's really interesting about the atomists is that they rejected the need to explain the original cause of motion.
So they didn't worry about what got the ball rolling, so to speak.
Exactly. They just accepted that motion is an inherent property of the universe.
Which is pretty consistent with modern physics, right? We don't really know what caused the Big Bang. We just know that it happened.
That's right. And I think it's a testament to the atomists' intellectual honesty that they were willing to acknowledge the limits of their knowledge.
Instead of just making up some story about gods or a prime mover.
Exactly. They were content to say, this is what we observe and this is how we understand it, even if it meant leaving some questions unanswered.
Which is a pretty humble approach, considering how revolutionary their ideas were.
It is, and it's a good reminder that true intellectual curiosity involves both asking questions and acknowledging the limits of our understanding.
So we've got these atoms swirling around in the void, colliding and combining to create the world we see around us.
And it's all happening according to natural laws without the need for any supernatural intervention.
It's a pretty amazing picture of the universe.
It is, and it's a testament to the power of human reason to unlock the secrets of the cosmos.
But I'm still wondering how all of this fits with Plato and his theory of forms.
Ah, yes, Plato and his world of perfect, unchanging forms.
Right. It seems like a pretty different perspective from the atomists' emphasis on the material world.
It is, but I think both perspectives offer valuable insights into the nature of reality.
So it's not about choosing one over the other.
Not necessarily. It's more about appreciating the different ways in which we can approach the big questions about existence, knowledge, and the meaning of life.
Like different lenses through which we can view the universe.
Exactly. And by exploring these different perspectives, we can gain a richer and more nuanced understanding of ourselves and the world around us.
So it's like a philosophical buffet where we can sample different ideas and see what nourishes our minds.
I like that analogy. And as we continue our journey through the history of Western philosophy, we'll encounter many more delicious dishes to savor.
Well, I'm definitely hungry for more. But before we move on, I want to take a moment to appreciate the atomists and their amazing insights.
Me too. They were truly pioneers of thought, and their ideas continue to inspire and challenge us today.
So, to wrap things up, what's the one big takeaway you want our listeners to ponder as they continue their own philosophical journeys?
I'd say it's the importance of questioning everything.
Even the things that seem obvious or self-evident.
Especially those things. Because as the atomists showed us, sometimes the most fundamental truths about the universe are hidden in plain sight.
It's like they were looking at the same world everyone else was looking at, but they saw something different.
Exactly. And that's the power of a curious and open mind. It allows us to see the world anew, to challenge our assumptions, and to discover new possibilities.
And that's what makes exploring the history of philosophy so exciting. It's not just about learning what people thought in the past. It's about using those ideas to spark new insights and understandings in the present.
Absolutely. So to all our listeners out there, keep questioning, keep exploring, and keep diving deep into the world of ideas.
Because you never know what amazing discoveries you might make.